Hi, now we are going to discuss code CodeChef 156 contest balance difficulties question. In question it says that it is given two conditions on an array. An array is given and on that array A we have to apply two conditions, that is AI is greater than or equal to AI minus 1 for all I is between in range 2 to n, and this means the ith element is greater than or equal to the previous element, right? What that means is the array is sorted, right? If one value is greater than or equal to the previous value, that means it is sorted, right? The first condition is sorted, the array should be sorted, and the next condition is ai minus 1 should be less than or equal to some value x, and this is also applicable for every value of I from 2 to n. This means the difference between two values in an array should be at most x. That means if we have a1 and a2, if we do a2 minus a1, this difference should be less than or equal to x. That means this difference should not exceed value x. In the question we are given with array B, of size n, and it says that in question it is sorted. That means this first condition is applied on the array before we are given that means the array is already sorted, then we are given that means the first condition is already satisfied, but the second condition is not satisfied. So to make the second condition to satisfy, we can make the array elements increase or decrease. That means if we have a element bi, we can add some value and we can also delete some value from that. These are two operations we can do, and we have to obtain an array c1, c2 and so on cn. This array should follow these two conditions, the first condition and second condition, and we have to calculate the cost of the array, which is defined as maximum value of ci minus bi, and this I ranges from 1 to n. That means for every value we have to find the ci minus bi value, and which is the maximum value we have to find, we have to say that as cost. This is cost. So in the question it is mentioned that we have to minimize this cost. What we should do, we should minimize the cost. Let's take an example and see how we can approach. Let's say we have b0, b1, b2, b3 and so on as an array. If x is equals to 5, that means the at most difference between two adjacent elements should be 5, and let's say the difference between these two values, that is b1 and b0, is 10. If we see, we have three approaches to make this difference as 5. What we can do, we can make this as plus 5, that means the difference is 10. So if we do plus 5 for this value, as it is sorted, we have to do plus 5 for this, so we will get some c0 value. This is one option. Then second option is we have to subtract 5 from this, so that the difference will be 5. So if we subtract this, we'll get some c1 value. If we don't want to do these both values, we can also do one more thing, that is we can add 3 here, we can subtract 2 here, right? If we do this, the the difference will go to 5. If we see, if we want to do these operations, after doing these operations we have to check for b2 also. If we see here, if we do that same operation, if we see here, we can't simply say that in these three operations we can do one to get this solution, right? This is called greedy approach, right? Isn't it? if we are going from one and each and everything and we are trying to get the best value from that, this is the greedy approach. But in this approach we are failing, because we can't say in that 3 which is the best in one attempt. So the next option what we have is, if we see any minimization or maximization problems, what we basically do, we go to binary search, right? We go to binary search, we just try to fix a value for mid, and check if this mid is satisfying the two conditions, right? If for this mid, let's say this mid is, we are considering this mid as our current cost. If we see this mid is satisfying our two conditions, we can say that this will be our answer. And as we have to minimize this, we can still reduce this minimum cost, right? We can reduce the maximum cost needed. We have to fix that value and we have to proceed further. Let's take an example and see how this goes. Let's say we took 2, 8, 10 and 12. If we see, this array is already sorted and the x value given here is x is equals to 1. That means the difference between each and everything should be 1. Let's assume our cost is 5. This is our assumption we are making. Actually we have to search from the minimum value to maximum value, and I'm directly taking the value and trying to see that whether this condition is satisfied or not. If we see 2, 8, 10 and 12, the difference here is 6, right? The difference here is 6, but we want 1. So what we can do, we can add 6 here. Sorry, we can add 5 here. Why we are adding 5 here? Because the cost is 5. That means the difference between CI and BI is 5. CI minus BI is 5. Okay, that is why we are adding the maximum value here. If we see this, the difference now is 1, right? Now the difference is 1. If we see the difference between these two values, that is 2 plus 2, right? The difference is 2. Now what we can do, if we try to change this value, that means 8, we can't get the correct answer, because if we change this 8 to some 9 or some other value or 11, the difference should be 1. So this value can be changed to 9 or 11, right? If we want to do this, our value will differ, right? For 7 it will not satisfy that condition, so we should not take that. Then what we need to take, we have only one option to change this. What we can do, we can do -1 for this. We can also do 8, 7 also. That means if we consider the next case, that means the difference between 9, the new value is 9, right? 9 and 12, we have 3. Our cost is 1, right? So we can change this value to 9, 8 or 7. If we change these values to 9, 8 or 7, the cost will vary, right? If we want to change these values, the cost will vary. So we have to take the maximum value so that our cost will be reduced. What we do here, for 9, if we want 1 as difference, what we can do, we can make this value as 10. That means we have to do -2. If we do -2, this is -1, we made it 9. Here we are doing -2, right? If you are doing -2, the maximum cost is, here we did not change anything, right? The maximum cost is, the difference between two values is, that is CI and BI is, maximum cost is 5. If we take here 5, we are trying to make this array to follow the above rules which are given, right? In what we are doing here, to generalize it, what we are doing here, if we have B0 and B1, we are trying to make this C0 as B0 plus our mid value, that is our cost value which we are considered. That for every mid value we need to check, so I'm using here mid value. So if we do this, we can change this, or we may change this, or we may not change this, but the first operation will be the same, right? Now let's take some other example, 2, 5 and 20. If you see this, let's say x is equals to 3. If we see 5 and 2 are already satisfying the condition, that means this can be placed as it is. If we see, if we want to make 20 as difference is 3, that means we can make it as 8 or less than 8, right? 8 or less than 8. Less than 8 we will have more cost, so we have to make 20 as 8. Then what is the difference here? We are subtracting 12 values here, that means our cost is 12. Can we minimize this cost? Let's say our cost is 8. Let's assume our cost is 8. What we can do, as the above thing, what we can do, we have to add plus 8 here. This will become 10, and if we also add 8 here, plus 8, it will become 13. If this is the case, what will be the next value? If we subtract 8 from here, that means 20 minus 8, it became 12, right? The difference between each and every value is 3, that is less than or equal to 3. But can we still reduce this value? If we take our cost value as 6, let's try to take our cost value as 6. If we take our cost value as 6, what will happen? We can add plus 6 here. If we add plus 6 here, this will become 11, and if we subtract 6 from here, it will become 14, right? The difference is 3, 3 and 3. So we are satisfying this condition. With lesser cost also we are satisfying. That means if we are directly trying to make 20, that means very big value of cost 12, instead of doing that, I'm nearly trying to reduce this cost by increasing these values, right? By increasing 2 and 5 to some other values, that means nearer values for 20, and I'm trying to do this. What is happening here? The relation between these two values is mid value, right? The cost value, this difference will be x, this difference will be x, and this difference will be mid value. This difference will be x. If we say, as we are increasing the values, if we see, we can see a case where if we are not able to make these values less than or equal to x, we can directly break that, right? Let's try to code it, like see the conditions what are happening here. If this value, that means here this is ci, right? This is ci minus mid value is greater than ci minus 1 plus x value. That means c minus 1 is 8. C minus 1 is 8, and current c value is 11. If we add x to this, that means plus 3, this will become 11, and if we subtract mid from this, that will become 5. If we have a condition where this value is very much greater than this current value, we can directly say this will be false. That means the x value is not satisfied, right? The x value is not satisfied. So in this case, we can directly say it is false. If not, what we can do, for every ci value, what we can do, we can take the minimum value of ci minus 1 plus x. That means for every previous value we are trying to add x, or bi plus mid. That means this value plus mid, this value plus mid. If we do that, for 2 plus mid will give us 8, and ci minus 1, that is, let's take this is I and this is I minus 1. If 5 is made 11, and if ci minus 1 is 8, right? If we add 8 to this, we can get some value. If we got two values, what is the minimum value in this 2? We can store in ci. This is the main logic for this. So let's try to code it. Let's try to see how the code goes. As we are using binary search, the low value will be starting from 0. That means the cost may be 0 and the end value can go till 10 power 9, right? The end value can go till 10 power 9. This is why, because the values in the array are, that means we are given with bi, so bi values are till 10 power 9. So at max the difference can be 10 power 9, right? At max, sorry, this is 0. At max the difference can be 10 power 9. So I'm taking the range from 0 to 10 power 9. If you see the binary search, low is less than or equal to, and let's take this as high, and this as high, low is less than or equal to high. What will happen? We have to find the mid value, right? If we want to find the mid value, low plus high by 2, and we are checking first, right? We are checking first what is happening in the function. If we found a value, if check function returns true, if this returns true, that means this is also a cost we can obtain for the following conditions, right? The following conditions are satisfied for this cost. So we can store this cost in some result variable. Let's say we are also having result here. Initially it is 0, or let's take it is end, because we have to minimize that value, right? This is high, sorry, we have to take it as high because we have to minimize that value. So we are storing this mid value so that we can minimize this. If we have to still want lesser answer, we can go to left, right? Now what we have to do, we have to go to left. How we can go to left? High is equals to mid minus 1, right? If this is not the case, what we have to do, we have to go to right, mid plus 1. After this everything is done, we can return answer directly, that is result directly. Now let's see the check function. What check function does is, we are passing mid to this. For let's take a last variable, that is the previous variable of our current value. That means if we have b0, b1, b2, if we are operating on b1, this will be the last value, right? To compute the values, this will be the last value. So I'm taking this as variable last, that means previous element. If we want the last element, initially it would be a of 0, that is b of 0 in our case, b of 0 plus mid value. As we did in the previous example, we did that. We added mid to this and we are storing that, right? The last value is this. And for every element, as we already considered 0, let's start from a1 till n minus 1. What will happen here? If the last value plus x is less than b of I minus mid, that means the case which we discussed here, this case, the same thing I wrote, let me write in reverse order so that you'll not get confused. B of I minus mid is greater than last plus x. Is this the same condition? This is the last value, that means previous value. This is the current value. We are subtracting mid from it and we are adding x to it. If we do this, if this is the case, we have to return false. Right? If not, if this is not the case, we have to update the last, as we did here. We are updating ci. We have to update the last to minimum value of bi plus mid comma last plus x. What will be the minimum value in these two? We have to update last to that. We are closing the for loop, we are closing the check function. And what to generate the answer, what we have to do to generate the answer, what we can do, let's say answer of 0 is equals to a of 0, that is b of 0 plus result. That means what result we got, that means minimum mid value, minimum cost value. That cost value is stored in result. Now for I is equals to 1 to n minus 1, n minus 1, that is from the 0th index is already filled, so from next index I am going to fill. Answer of I would be minimum value of b of I plus result, comma, answer of I minus 1 plus x, the condition which I wrote previously also, that is this condition. The last value, what we are doing here, I'm doing the same there, I'm using the same procedure there to identify the answer. This is the case. After doing this, we'll return the answer and close the function. And what is the time complexity for this? What will be the time complexity? For binary search, it will be n log n. For binary search, it will be n log n. That is because we are calling the function, check function n times. That means in check function, we are having a loop which runs for n time, and the function, the binary search goes for log n times, plus this one. What is this costing? N. So we can take in bigger terms n log n, right? And what is the space complexity? As we are not using any extra space, and the input and output are already arrays, so this answer will not be considered in the extra space we are taking, so the time would be constant. Thank you.